Alright, so we're going to cover combining functions, composite functions in a kind of condensed form here, but this should get you through your notes and get all the main ideas. Essentially what we're doing is given two functions, we're going to find their sum, difference, products, and quotients right now. So this is just our regular combining them, adding them, subtracting them, multiplying them, things like that. The domain of each new function consists of those values of x that are common to the domains of f and g, except if you have an f divided by g whose values of g of x would be 0. So in other words, as long as it doesn't make you end up, if there isn't something in a domain where you end up dividing by 0, then anything that's in the domain of one of them is going to be the domain of both. So let's take a look at this here. We're given f of x equals x squared minus 6x plus 8, and g of x equals x minus 2. And then we're going to find the following combination. So first, we want to know the domain of f. Well, f, if you look at it, we don't have any square roots, we don't have any division, so it's just going to be negative infinity to positive infinity. And if we look at g, we've just x minus 2. Again, no radicals, no division, so negative infinity to infinity. We can plug anything we want into those. So if we look at this one, this is telling us to simply add them. F plus g of x is the way you would read that, and it's simply going to equal f of x plus g of x. And in this case, f of x is x squared minus 6x plus 8, and g of x is x minus 2. And so at this point, you just start distributing, go through, combine like terms. You have x squared, there's no other x squared terms. You have a minus 6x and a regular 6, so that's going to be a minus 5x. And then you have an 8 and a negative 2, which will just be a plus 6. And then to find the domain, it is simply again, the domain of each new function consists of those values of x that are common to the domains of both. Well, what's common to both? Negative infinity to infinity. So it's common to both, therefore we're good. So common to the domains of both, except for what's going to make that 0. And these domains overlap totally. So next we're going to do f minus g of x, which is f of x minus g of x. That's what that will equal. And so that's going to be similarly x squared minus 6x plus 8 minus, this time, x minus 2. Okay? And so now we just need to combine again, but this time we have to distribute that negative sign. So we'll have x squared minus 6x plus 8, and then we have to do minus x and then minus negative 2, so plus 2. And so here we get x squared, the only x squared term. We have a negative 6x and a minus x, that's minus 7x. And then we have a plus 8 and a plus 2, that's a plus 10. And again, the common areas, we don't have to worry about dividing by 0. These overlap, common, negative infinity to infinity. All right, this one is f times g of x. So this equals f of x times g of x. And so we plug these in. X squared minus 6x plus 8 times x minus 2. And so at this point, you would go through and start term by term multiplying. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Then we move to the 6x. So negative 6x times x is minus 6x squared. Negative 6x times negative 2 is plus 12x. Then we do the 8. 8 times x is plus 8x. 8 times negative 2 is minus 16. Go through, combine all the like terms. There's only one x squared, x cubed. There's a 2x squared term, so that's a minus 8x squared. We have a 12x and an 8x, that's a 20x, and then still the minus 16. And again, and then here again, we've got the domain just being the common points, which is just negative infinity to negative infinity. Now here in this one, we're doing division, so we may have to worry about anything in the domain of g that would make the denominator 0. So what we have to do is go ahead and just do this first. This is f of x divided by g of x, okay? And that's going to equal f of x is the x squared minus 6x plus 8 over x minus 2. Now, to do this, you can factor the top, the numerator, and it factors to x minus 4 times x minus 2 over x minus 2. And when you do that, you can cancel out the x minus 2's, right? You can cancel them out and get x minus 4 left. Now, when you go to figure out the domain, you look at x minus 4 and you want to say, hey, that, I can plug anything I want into x minus 4. But the problem is you have to look at the domain of g, because along the way, as you do this, anything that makes g 0 is gonna make this fall apart. So if we look back at the previous lines, we notice that if we plug in 2 for x, that's going to make the x minus 2 equal 0. So we can't have, even though it canceled out, we can't have it equal to 0, which means we can't have x equals 2 in our domain. So our domain here is going to be negative infinity up to 2, but not including 2, and then a union of 2 out to infinity, just like that, okay? So I'm going to leave these last two for you to try. Notice they aren't of x, but they actually have numbers filled in there. You try them, and in the notes, I'll actually have them completed for you. You can go look there, but right now, just try them yourselves and see what you get. And if you need to, go look at the notes online to see what the answers are. All right, now we're going to talk about composition functions. This is when we take functions of functions. So if f and g are two functions, the composition of the function f with the function g is written as f of g and is defined by the equation f of g of x equals f of g of x. And that's the way you would read this. That's the way it's written. Notice this isn't a times symbol, it's a little open circle, but this is read f of g of x. Okay, that's how you would read that one. And so here, the domain of f of g consists of those values of x in the domain of g for which g of x is in the domain of f of x. Okay? So you have to be kind of careful with that. You have to make sure that even if your final result seems like it can handle it, you have to have it has to make it through g of x first, is the way I think of it. So what's basically happening here is you're going to plug a value in, it has to survive through g of x, and then make it through f of x. So it's the values of x in the domain of g for which g of x is in the domain of f of x. So what I'm saying here is, like, say for example, if I plug in something, say 7 isn't in the domain of f, and the result of g of x is 7, then it's not going to work, because it's going to give you something into f of x that's going to break it, okay? And the symbol, this is read as of, as I was describing above, and it's not the same, not the multiplication symbol. All right, so let's take a look at these. Let's try this one here. We've got g of x equals x squared minus 1, and f of x equals square root of x. And so we're going to first input something into the g of x function, and it's going to do something, and it's going to output a value, and then we're going to take that value and input it into f of x. So let's try this. If we just want to try, say, f of g of x, that's f of g of x, like that. And so we take and we do f of, what is g? G is x squared minus 1. And then we go through and plug that in. And since f of x is square root of x, this is square root everywhere there's an x, we're going to replace with an x squared minus 1. And there's f of g of x. okay? And so that's essentially kind of the way that you will have to do this. And again, if there's something that is a result from g of x, if it comes out of g of x, and that value that comes out of g of x breaks f of x, then it can't be in the domain of the composite function, okay? All right, so let's take a look here. Finding composite functions. Let f of x equal 2x plus 1 and g of x equal x squared minus 3, and we're going to find the following. So let's do g of f of x. That's g of f of x. That's going to be g of, what's f of x? F of x is 2x plus 1, so g of 2x plus 1. And then 2x plus 1, that's where we're going to go ahead and substitute it in for everywhere there's an x. So that's going to equal 2x plus 1, that's where we have our first x, and it's squared, and then minus 3, okay? And so then this is going to equal 2x plus 1 squared, that's going to be a 4x squared, right? We're just going to FOIL this thing out. Then a, so this is 2x plus 1 times 2x plus 1. And so we get a 4x squared, we get a plus 2x, another plus 2x, and then a plus 1, just like that. And then don't forget the minus 3, and so this will equal 4x squared plus 4x, and then 1 minus 3 is negative 2. All right, and so there is our composite function. For this one, we're doing f of x, so that's f of x, and so that's going to be f of 2x plus 1, and so then we just actually use the function f, and so that's 2, replace x with 2x plus 1, and then plus 1. Okay, so something like that. Distribute, you get a 4x plus 2 plus 1, and that gives you a 4x plus 3. Okay, so there's that one. And again, I'm going to leave this next one for you to try, but it'll be in the completed notes online, so you can go take a look at it. I don't want this video to be too horribly long. Next, and probably a bit more of an important skill, is the decomposition of functions. Here you need to be able to look at these and figure out what the inner and outer functions are. Technically there can be multiple correct answers to this, but we want to kind of look for the more general ones. All right, so remember this up here is equal to f of g of x. Okay, and so we want to figure out what f and g are that would make up this. Now g of x is the inner function, so we're going to plug it in to f of x. So we might look at this and say, all right, well, to me it looks like I have a square root around something, so I might say, all right, well, I'm going to make my outer function just square root of x, and then my inner function can just be what did I plug in for x to give me what's inside there, and I can make that 2x squared plus 1. And so if I try this now, if I did f of g of x, I would be replacing the square root of x, I would be replacing the x in the square root of x with 2x squared plus 1, and it'd give me back my original. So if you actually try to do f of g of x, you should get the original. So let's take a look at this next one. Okay, we're going to decompose it, and so if we look at this one, we actually have a couple of options here. I mean, and we have a couple options in the first one too, but how about this? What if we did g of x and f of x, right? And to me, I see that x to the 10th out on the outside, so I want to make this an x to the 10th. And then I just need to replace the inside, so I'll make this x squared minus 3. So if I do f of g of x, I replace this x with x squared minus 3, and I'd have the quantity x squared minus 3 all to the 10th power. Or I might have looked at this a little differently, and I might have said, well, what if g of x was x squared, and then I could make f of x simply equal to x minus 3 to the 10th. And so here's two different options. They're both correct, and they'll give you the same thing. If I replace this x with x squared, I'll be right back to the original. Okay? So for these next ones, this is f of x, g of x, h of x, and everything like that. And we want to express each of the functions below as a composite involving one or more of f of g, h, or j. Okay, so how can we use f, g, h, make a composite to get these? Well, if we look at the first one, I see the square root and I see the x minus 3. So we have an x minus 3 here and we have a square root here. So I look at that and I think I'm going to want to combine those two together. And if I put the x minus 3 in for f, so if I do f of g, if I do g of f, then I'm going to end up replacing that and I'll have square root of x minus 3. I'd end up with square root of x minus 3, and that's not quite what we want. But if I flip it around the other way, where I substitute in square root of x for x, then I'll get the answer I want. So I'm going to want to do f of g of x, or f of g of x, like that. Okay, and if you try that, you'll see that you should get it. So I'll do one more of these, and then I'm going to leave you to try the others and just put the solutions in the notes online. So for this one, again, I see that square root of x, so I immediately start thinking about g again, but now I have a times 2, and this one has a times 2 in it, so I'm going to want to combine those two together. And so if I do j of g of x, that should work for me. I'm going to replace the x in the 2 times x with square root of x, and that'll work. You can also write this j of g of x, like that. Okay, and again, try these next ones on your own, and then see the online part for answers if you need to. Same thing, well, that's pretty much it. Same thing for this one and that one. So any of the ones that I didn't complete in here, go take a look online for the completed versions of these, so that you can try them and see if you got them right or make corrections accordingly. All right, that was it.